so our base coordinates are A and C. So the distance from A to C, that's what I'm trying to find. So that's the x coordinates, the difference between the x coordinates, -3 minus 5, the quantity squared, plus the difference between the y coordinates, 1 minus 1, the quantity squared. Well, -3 minus 5 is -8. 1 minus 1 is 0, so I don't have to worry about that. -8, the quantity squared is, well, negative times a negative is a positive. So that comes out to be the square root of 64, which is 8, which is exactly what we want. So hopefully you guys, in doing the distance formula a million times over and over and over again, you have realized two things. One, I showed you, I kind of explained in that first video that distance formula comes from Pythagorean theorem. And the reason that we square it is squaring gets rid of the negative. That's why we square it, because you can't have something that is negative distance, right? So I see that the difference between -3 and 5 is -8, but distance isn't negative. It's only positive. So that's why we square it and then take the square root of it. We've gotten rid of that negative sign. That's all that we're doing. That's the only thing. So I know that my base is 8 units. Now we need to find the height. And I'm going to find the height using distance. But I don't even have a height drawn in there, so I need to draw that in. And my height is perpendicular to the base. So I'm going to draw my height in. And I'm going to name this point right here. I have to name this coordinate. So I'm going to call this coordinate D. And I need to figure out what that ordered pair is. So remember that the height always goes from a vertex perpendicular to the opposite side. So that's what I've drawn there. What is coordinate D? Yeah, it's the ordered pair 1, 1. So I need to find the distance from B to D. So the x coordinates, 1 minus 1, the quantity squared, plus the y coordinates, 6 minus 1, the quantity squared. Well, 1 minus 1 is 0. 6 minus 1 is 5 squared is, the square root of 25 is 5. And again, I could probably have just counted those. 1, 2, 3, 4, 5. But because it's coordinate geometry, we have to prove it. Does that make sense? It's not enough just to count them. Okay. So let's use the area formula. The area equals the base times the height divided by 2. We just said that our base is 8 and our height is 5. We're going to divide that by 2. So 8 times 5 is, divided by 2 is 20. So my area is 20 square units. Okay. Are we good with that? All right. So the next shape is a quadrilateral. Let's go ahead and graph it, and then we'll figure out how to figure out the area of that. So let's see. 6, 1 is D. 2, 4 is E. -5, 4 is F. And -1, 1 is G. So it looks to me like DEFG is a parallelogram. I could check very quickly to make sure that these have the same slope. Down 3 over 4, down 3 over 4. So I know that this is a parallelogram. So what type of a quadrilateral is it? It's a parallelogram. because two pairs of opposite sides are parallel. So we have to calculate the area. So the area, remember, is the base times the height. So the base is this measurement right here. This is my base. But I don't have a height drawn in there. And remember, the height needs to be perpendicular to the base. So where do you want to draw the height? Someone go grab a marker and go up there and draw the height for us. There are two really good places that you could put your height measurement. Has to be from a vertex, perpendicular to the other side. So what if I started here? Where would I have to go to draw the height? Up. I would have to go up. So this could be my height. But what if I started here? I would have to go down, and this could be my height. It doesn't matter which measurement you use, they're both going to be the same. So we need to label this coordinate. We either need to create a coordinate here or a coordinate here. You guys decide which one you want to use. Someone tell me. Which one? The E one? So we're going to use the line segment that has E in it. So this coordinate right here, we're going to call it H, is the ordered pair 2, 1. Does everybody see that? So the base is the distance from G to D. And the height is going to be the distance from E to H. So let's find the distance from G to D first. So 6 minus a negative is 6 plus 1, the quantity squared, plus 1 minus 1, quantity squared. So what's 6 plus 1? 7 squared is 49. What's 1 minus 1? 0. So we're not going to square it. We just know that we have the square root of 49, which is 7. And that makes sense because this is 1, 2, 3, 4, 5, 6, 7 units. So we did that right. Let's find the height. So we could count it and see that it's 3. We need to prove it, right? So E, 2 minus H, 2. So 2 minus 2, the quantity squared, plus 4 minus 1, the quantity squared. Well, 2 minus 2 is 0, and 4 minus 1 is 3 squared is, and the square root of 9 is. Okay. So I have my two measurements. Remember that the area is just the base times the height, because this is a parallelogram. So the area is 7 times 3, which means that the area is 21 units squared. So it asks me to calculate the perimeter. How am I going to do that? Perimeter is what? Adding up all the sides. So we know that G to D is 7, which means that E to F is 7. That's the definition of a parallelogram, right? Opposite sides are not only parallel, but they're congruent. So these are both 7. What do I have to do to find either the distance from FG or ED? Distance formula. So let's do the distance from F to G, and then we'll take that and just double it for the other side. So the distance from F to G, well, let's see. That's negative 5 minus a negative, which becomes plus 1 squared, plus F is 4 minus 1, quantity squared. So negative 5 plus 1 is negative 4. squared plus 4 minus 1 is 3, the quantity squared. So let's see. That becomes 16 plus 9, which is 25. And the square root of 25 is 5. And that makes sense because we're trying to find this measure right here. And if I were to turn this into a triangle right here, just off to the side, this is a 3, 4, 5. Remember learning about Pythagorean triples? We did that in one of our notes. I talked to you guys about Pythagorean triples. So these are both 5. So the perimeter is 7 plus 5 plus 7 plus 5, or 24 units. And perimeter is not squared like area is. Perimeter is not squared like area is. Sometimes you're going to have a shape that you have to divide into smaller, more manageable shapes, especially if it's something that has more than 4 vertices, like this 6 verticed polygon. What is a polygon that has 6 sides called? Do you guys know? It's called a hexagon. Who said that? Good job, Lainey. You can have a candy after class. Not after class, just after we get through the notes. Okay. So we have a hexagon. So let's plot our points. A is the ordered pair 4, 0. B is the ordered pair 3, 3. C is the ordered pair -1, 3. D is the ordered pair -4, 0. E is the ordered pair -1, -3. And F is the ordered pair 3, -3. So I'm going to connect all my points. So I have something that looks like that. So do you see some shapes in there? Like, I'm going to come up in front. Do you see some shapes that we could separate that into? What do you think? Give me. Huh? A couple of triangles? Yeah, I could go this way and this way. And that would give me a triangle, a rectangle, and a triangle. Okay? Does everybody see that? Is there easier? So we have to find the area of 3 shapes if I did that. Does anyone see anything else we could do? 2 trapezoids. Yeah. You could just draw a line right like this. And we could find the area of 2 trapezoids. Okay?
Wouldn't say like if you took those 2 trapezoids, I think they're all shaped completely.
Well, they reflect. One is a reflection of the other. Yes, I could flip this over. So if I find the area of 1 trapezoid, I can just multiply that by 2 and find the area of both of them together. You guys see that? Because these are congruent. They have the same slope from one to the other. They're just opposites. Same slope, they're just opposite. Yeah, so let's figure out the area of 1 trapezoid and then just double that. So if I'm going to find the area of a trapezoid, that means I need to find the 2 base measures, B1 and B2, and I have to find the height. So we're going to do this. Whoops. That's so cool. I didn't know that I could do that. Ooh, I don't want to do that though. I don't know how I just did that. Undo, go. Okay. Let's try that again. So this is, oh my gosh, what the crazy. Okay. So here we go. This is our 2 trapezoids. So we have 2 congruent. That symbol means congruent, equal with the little squiggly over the top. We have two congruent trapezoids. So we're going to use the B1 plus B2 times the height all over 2 formula. So if we think about B1, we need to find the distance from B1, and we're going to say that's the distance from B to C. So this is our B1. We have to find the distance of B2, which is going to be A to D. You don't have to put them in ABC order. That's just my brain. And then I have to find the height. Ooh, where in the heck is the height of this trapezoid? Because it's not drawn in for us. C down. Perfect. So what do you want to name this point right here? What letter do you want to give it? Sure. And what coordinate is G? Negative 1, 0. Good job. So we also have to find the distance of C to G. Okay. Let's find the distance of B to C first. So 3 minus a negative is plus. So 3 plus 1, the quantity squared, plus 3 minus 3, the quantity squared. Well, 3 minus 3 is 0, right? 3 plus 1 is 4. 4 squared is, and the square root of 16 is. And that makes sense because we could count 1, 2, 3, 4, but we have to prove it. Now let's find the distance from A to D. A, the x-coordinate is 4. D, the x-coordinate is negative 4. 4 minus a negative 4 becomes 4 plus 4, the quantity squared, plus the y-coordinates, 0 minus 0. So 0 minus 0 is 0. 4 plus 4 is 8, and 8 squared is 64. The square root of 64 is, and that makes sense, and I could count that. 1, 2, 3, 4, 5, 6, 7, 8. And I do count it when I do them just to make sure that I'm not doing something crazy, because it's real easy to do crazy math when you're doing the distance formula. Let's find the distance from C to G. Okay, so C, the x-coordinate is negative 1 minus negative 1, so that becomes plus 1, quantity squared. And the y-coordinate, 3 minus 0, the quantity squared. All right, negative 1 plus 1 is 0. So 0 squared is just 0. We're gonna ignore that. 3 minus 1 is 3. Squared is, sorry, 3 minus 0 is 3. 3 squared is, and the square root of 9 is, okay. So the area is the height, which we said is 3, times B1, which is 4, plus B2, which is 8, all over 2. And that's going to give us the area of just one trapezoid. So when we're all done with that, we're going to take our answer and multiply it by 2. Does that make sense? Okay, so can I do something? Do you guys see what I just did? Right? If I'm going to take the half something and divide it by 2, but then multiply it by 2, don't those just cancel out? Okay, so I just really need to figure out what 3 times 12 is. And 3 times 12 is 36 units squared. What do you think? Okay, sometimes you just need someone to like walk you through it. All right, so we have more irregular shapes that are probably going to require us to like do some smaller shapes from the inside of it, okay? So we have triangle ABC. A is 1, 3. B, that would be awesome. B is 5, 2. And C is -3, -3. So unfortunately, this is not a nice triangle. So it'd be really hard to figure out where the perpendiculars are to create this, to like figure out the area of this shape. Okay. So at the beginning, it says if you're trying to find the area of a really irregular shape, sometimes we surround it by a rectangle or a more regular shape that has triangles that we can cross out. So I'm going to turn this into a rectangle. I'm going to do that by going as far over as I need to go to the right. So I just need to be lined up with the B. I'm going to go as far up high as the highest ordered pair is. And then I'm going to go as far left as I need to go to be lined up with the C. And then I'm going to go down. So essentially, I have a rectangle, which is what? Length times width. So here's kind of the idea. We're going to take the area of the rectangle, and from that, we're going to subtract the area of triangle 1 and the area of triangle 2 and the area of triangle 3. So I'm going to just call it area of triangle 1 plus area of triangle 2 plus the area of triangle 3. Okay, so first thing that we have to do is find some coordinates here. So I'm just going to start at Z, and I'm going to label this Z, I'm going to label this X, and I'm going to label this Y. So I need to find the area of the rectangle first. So I need to find the distance of ZX, and I need to find this distance of XY. That'll give me the area of the rectangle. So someone tell me what to put in there. Well, we need to name these points, right? Can we name these coordinates? What is Z? -3, 3. What is X? 5, 3. Good job. And Y is 5, -3. Okay. So if I'm finding the distance from Z to X, subtract the X coordinates, I have -3 minus 5, the quantity squared, plus 3 minus 3, the quantity squared. Well, this becomes 0, right? 3 minus 3 is 0. So -3 minus 8, -3 minus 5 is -8. And when I square -8, I get 64. And the square root of 64 is 8. And that makes sense because I could count 8 units there. Now let's find the distance from B and X are the same coordinate. That's all right. X to Y. So let's find, no, they're not. X to Y. So I'm going to go from X to Y. So X, 5 minus 5, the quantity squared, plus 3 minus a negative becomes plus 3, the quantity squared. Well, 5 minus 5 is 0, so I just kind of ignore that. 3 plus 3 is, squared is 36, which equals 6, right? So the area of my rectangle is 8 times 6, or 48. Yes or no? Got it? So now we need to find the area of triangle 1. So how are we going to do that? What sides do we need to have? Yeah, I have to do ZC and I have to do ZA. That's going to give me triangle 1. And I can count them. I know that. But again, we're doing coordinate proofs. So Z, -3, minus C, which is also -3. So -3 plus 3 squared plus 3 minus, which becomes plus the quantity squared. So the -3 and the +3 cancel out. 3 plus 3 is what? 6 squared is. The square root of 36 is 6. And that's how many units this is. 1, 2, 3, 4, 5, 6. Now let's find the distance from Z to A. So the Z coordinate, -3. The A coordinate, -1. Plus the Z coordinate, 3 minus 3. All right. So -3 minus 1 is -4. And 3 minus 3 is 0. So I just have -4 squared, which is what? -4 times -4 is, and the square root of 16 is 4. So the area of triangle 1 equals the base, 6, times the height, 4, divided by 2. 6 times 4 is 24, divided by 2 is 12. Are you guys with me? Okay, now we need to find the area of triangle 2. So what are the two sides that make up the area of triangle 2? Triangle 2 is this triangle right down here. So I don't want the hypotenuse. I need the base and the height. Remember, they're perpendicular to each other. CY and BY. Good job. So I'm going to find the distance from CY and the distance from BY. So CY, let's see. The C coordinate on the X side, -3 minus 5, the quantity squared, plus -3 minus a negative becomes plus. So -3 minus 5 is -8. This cancels out. So I have -8 squared. What is -8 squared? 64. And the square root of 64 is 8. Are you guys seeing what's happening here? Every single time one of those cancel out? It's because they're vertical and horizontal lines, right? All right, the distance from B to Y. I'm going to write small here. Get small. So B, 5 minus 5, the quantity squared is 0, plus the Y coordinate, 2 minus a negative is plus. So this cancels out. 5 minus 5 is 0. 2 plus 5 is, 2 plus 3 is, squared is, and the square root of 25 is 5. So the area of triangle 2 is the base, 8, times the height, 5, divided by 2, which means the area of triangle 2 is 20, correct? Yes or no? We got it? Last one, area of triangle 3. That's a teeny tiny one. So I need to find the distance from A to X, and I need to find the distance from B to X. Let's do A to X first. So A, 1 minus X, 5, the quantity squared, plus Y coordinates, 3 minus 3. Let's see, 1 minus 5 is -4. -4 squared is 16, and the square root of 16 is All right. Let's find the distance of B to X. So B, 5 minus 5, the quantity squared. Well, that's 0 plus 2 minus 3, the quantity squared. 2 minus 3 is negative 1. Negative 1, the quantity squared is 1, and the square root of 1 is 1. So the area of triangle 3 is the base, 4, times the height, 1, divided by 2. 4 times 1 is 4, divided by 2 is 2. So now let's find the area of everything. So remember that the area of the original triangle, triangle ABC, is the rectangle, which we said was 48, minus the sum of triangle 1, which was 12, plus triangle 2, which was 20, plus triangle 3, which was 2. So 48 minus 34 equals 14 units squared. And I know that was a lot. I actually did all my work on a separate sheet of paper because I didn't think I'd be able to fit it in there. Okay. I know these are time consuming. That's why you really don't have more than 6 or 8 questions. Can we do the last example? Are we still working? Alexis, do you feel like you need to vomit? You're hating this? Okay. Quadrilateral ABCD has vertices with coordinates. So it's a quadrilateral, 4-sided figure. So A is the ordered pair 1, 4. B is the ordered pair 2, 3. C is the ordered pair 0, negative 3. And D is the ordered pair negative 3, 1. So I'm going to connect my fabulous points here. I'm going to do the exact same thing. We're going to turn this into a what? A rectangle. We need to go as far to the right to cover all the points, as far to the left, as far up, and as far down. Okay? So if I start at A, how far right do I need to go to connect, like to get all of the points the farthest right? How many units do I need to go over? Just 1. Do you see that? And then I need to go down all the way to kind of close the gap with C. So I'm going to go down to here. And then I need to go all the way to the left to be even with D. And I need to go all the way up to be even with A. And then I need to go all the way back over. So let's find the area of the rectangle first. I'm going to let you count it. Area of the rectangle. How many units is it? 1, 2, 3, 4, 5, 6, 7 units times 1, 2, 3, 4, 5 units. So the rectangle is 35 units squared. Okay. Let's name our triangles. Triangle 1, triangle 2, triangle 3, and triangle 4. I'm going to let you guys count these, okay? Because Alexis is going to fall asleep on me. Area of triangle 1. Alexis, what are the 2 sides, the base and the height, that make up triangle 1? You got this. Look, right here. This is triangle 1. What's the measurement of the base and what's the measurement of the height? Am I putting you on the spot? Okay, pass it on to your seatmate, Ava. How many units is this, Ava? If I go from A over to right here, how many units is that? 1, 2, 3, 4. Let's count my height. 1, 2, 3 divided by 2. So what's the area of triangle 1? 6. Let's find the area of triangle 2. Courtney, I'm starting with you. What's my height? And my base? So 4 times 3 divided by 2 is 6. We just did that. Tessa, I'm going to you for the triangle 3. What's this measurement right here? My base times my height? Yeah. So I have 2 times 6 divided by 2, which is 6, right? Area of triangle 4. How many units is this? And this one? 1 times 1 over 2 equals 1/2. Okay. So if I take 35, the area of my rectangle, minus the sum of 6 plus 6 plus 6 plus 1/2, well, that's the same thing as saying 35 minus 18.5. And that equals 16.5. So 16.5 units squared. All right, so I'm going to talk to you about homework. You have 6 questions. 6 questions for your homework. So this one, perimeter and area, perimeter and area, perimeter and area. It tells you for number 3 that it's a parallelogram. The other 2, it doesn't tell you what it is. It just says it's a quadrilateral or a triangle. Number 4, you're finding the area of a pentagon. Let's graph these really fast so I can help you break it up. Is that okay? Anything that's more than 4 points. So for number 4, E is the point 6, 1. F is the point 4, 3. G is the point -2, 3. H is the point -2, -1. And J is the point 4, -1. So this is much like the one that we did the last, it's much like the hexagon. 2 what? 2 trapezoids. Or, is that what you said? Okay, you can turn it into 2 trapezoids. What else could you do? Oh. Yeah, you could do a triangle and a rectangle. The erase button is a little slow on me. Yeah, I could do a triangle and a rectangle. Okay. Use whatever method works best for you. Trapezoid, straight up trapezoid. So the last 2 are just trapezoids. You should be good with those. Okay. You're just finding the area. Remember the formula for a trapezoid? Area, height times B1 plus B2. Remember your height and your bases are perpendicular to each other. You're going to probably have to draw on your height. Your B1 and B2 are your parallel sides. Okay.